right, welcome to a sponsor session. Thank you for attending. We really appreciate it. You know, when we have these kinds of events at Hewlett Packard Enterprise, there's usually an email that circulates to the employees in the background that says, "Hey, look, you need to go to the sponsor sessions. They're the ones who pay for a lot of this. They're the reasons we can have nice things." And I understand that people can hesitate a little bit to go to a sponsor session because they're usually big on hyperbole and somewhat low on detail. And hey, this is an engineering event. Well, I am not a marketing person. I'm not a salesperson. In fact, I couldn't sell you a dollar for 99 cents. So who am I? Who am I? So my name is Craig Lamparter. And for the past 28 years, I've worked with Hewlett Packard Enterprise. My official title is a Linux systems software engineer, where I work in our Linux enablement laboratory, ultimately, where our goal is to make Linux on ProLiant the best combination in the industry. As I'm sure you can tell from my U.S. English accent, I am in fact from the United States of America, specifically from the left side over here in the California Republic. You might further assume I'm from Silicon Valley, with our shiny new headquarter building there and employees doing interesting stuff in the backyard. Actually, you'd be wrong if you assumed I was from the Bay Area. I'm not. I'm actually from the other side of California. And this is a picture of me doing stuff in what is ostensibly my backyard. So we didn't come here to talk about myself or geography. We're here to talk about Linux enablement on HPE ProLiant servers and really what that means. And especially with a SUSE spin on it for SUSECON. So this is the obligatory agenda. I'm a KDE guy, so you're going to see KDE icons throughout this presentation. So we're going to talk about how we work with SUSE as a partner, and we're also going to talk about our hardware partners, how we work with them, kind of in a three-way scenario. We're going to talk about the service pack for ProLiant, which is drivers, agent software, and firmware. You're going to hear me say those three things over and over. We'll talk a little about HPE Linux value add software. And then ultimately the one URL that you might want to take away from this presentation, and that's downloads.linux.hpe.com it's our online software repository. All right, so working with SUSE. So hey, this is SUSECON. This is probably pretty remedial for all of you here. But SUSE, there's a variety of SUSE-based Linux distributions. The one we're going to be talking about the most today, obviously, is SLES. But don't forget, we've got OpenSUSE, Leap, and Tumbleweed. When we talk about SLES, this is where we put all of our effort and all of our support and certification. We work really closely with SUSE to make sure SLES works perfectly on HPE ProLiant servers. We have these technical reference forums. We're meeting all the time, or at least on a regular schedule. We lock ourselves in rooms, work out roadmaps, technical issues, and design stuff. We have shared engineering resources, like you'll see SUSE people on the Houston campus here in the United States, and you might even see me in Nuremberg, right, at the SUSE building there. So ultimately, when we're talking about the partnership, you're getting full integration testing before we launch a product. So SLES is always going to work on a brand new server. They don't always, right? It takes some effort. It doesn't just happen. Specific to SLES, so you can buy entitlements directly from HPE or SUSE. Everything's certified by HPE and SUSE as a result. And of course, with SLES, entitlement and support purchase is in fact obligatory. So when you install SLES, you need to purchase, that support. Ultimately, it pays for all of this, integration work that I just talked about. So in talking about these other distributions, these aren't really in any order of technical merit at all. In fact, if anything, Tumbleweed is going to track the latest Git kernel. And honestly, it's not hard to enable these because they do have the latest drivers in them all the time. We don't have to work with SUSE to backport drivers into the kernels with the stable ABIs, kernel ABIs. So there's no support or certification with these guys, but it doesn't mean they're a lesser Linux distribution in any way. In fact, they're pretty cool. But for the emphasis of this presentation, we're going to talk about SLES. So that was our operating system partner, SUSE. So we've got a lot of hardware partners that we need to work with as well from a Linux perspective. I mean, a lot of these drivers are actually written by these hardware partners. So we really do have to partner with them and SUSE all at the same time to get everything to work together in concert perfectly on day one, right? It's not the easiest task. So CPU stuff is kind of obvious. We've got AMD, Intel, and ARM. AMD obviously making a resurgence there. I mentioned microcode here because we do have to manage a CPU. A CPU isn't just some static object. There's actually firmware in a CPU in the form of microcode, and that's something that has to be managed. Looking at NIC and fiber channel stuff, boy, this industry has been in turmoil is a strong word. I don't want to say turmoil. It's been in a lot of change, a lot of flux. And actually, I had to write it on this slide so I wouldn't forget it. So over recent years, Broadcom tried and failed to acquire Emulex. Avago acquired Emulex, and then Avago acquired Broadcom, and then Avago changed their name to Broadcom. So I guess they got that acquisition done that way. So that's an interesting turn of events. More recently, Mellanox was acquired by NVIDIA. QLogic changed to Cavium at some point. And I know this sounds like it was just some horrible situation, but it's really not. All of the same great people work for these companies, and a lot of them are managed like wholly owned subsidiaries. We're still working with them really closely, despite some of the organizational changes. Hey, that's what we'll call it, organizational changes. And the reason I put this slide together is to kind of give you an idea of what the drivers are for each one of these things. So, if you do an LS mod on your ProLiant and you see MLX5 drivers, that means you got Mellanox cards, right? Or at least drivers loaded for Mellanox cards. If you see TG3 or BNX, you're looking at Broadcom. The MLX drivers are here. QLogic's easy. Those always start with QLA. And then Intel NICs generally always start with an I. Well, for Intel. Um, so that's our network and fiber cards, the drivers around those. And for storage, if you've worked with ProLiant over the decades as I have, you've seen a lot of iterations of the HP Smart Array driver. Way back in the Compactian era, we had the Kisses driver. That went for a long, long time. Then we had a couple of proprietary drivers, HP VSA and DSA. These were controversial. Ultimately, these implemented the Smart Array hardware in software in the driver. So it's kind of like a software RAID scenario. But again, those weren't open source, so we couldn't really ship them with SUSE and SLES. We had to deliver those outside of the operating systems. And then we had HPSA. This had a good run. This had like 12 years, I think. And more recently with Gen 10, we now have Smart PQI. And the PQI, I can't remember what that stands for. So anyways, the new Smart Array has something called PQI command queues. That's why we call it PQI. There's a bunch of them, so we get this massively parallel I/O stuff. So from a Linux perspective, you need to have a driver called Smart PQI in your kernel to drive the latest Smart Array in HPE Gen 10 servers. If for some reason you are using a lesser distribution, or I should say not lesser, an older distribution that doesn't have it, the legacy AAC RAID driver will pick that up kind of in a limp mode. It'll be really horrible in performance, but you'll get the system installed to the point where you can install the Smart PQI errata driver. Now, of course, if you're using SLES, you don't have to worry about any of this. We've made sure all of this just works perfectly. And of course, we've got LSI, SATA adapters, disk drives. I want to mention those because the disk drive has firmware and software to manage as well. And lastly, we have management ASICs. If you're familiar with our servers, we have HPILO integrated lights out management processor. Gives you virtual console, virtual media. All of your hardware management and telemetry data is provided by that management processor. We have an HPE Watchdog timer, and this is its driver. And we have the TPM module in there as well. We're talking about silicon root of trust. I don't think this guy gets enough love. We should really be putting certificates in hardware and validating our software containers, from a silicon root of trust here. In fact, I'd like to get this all the way back to secure boot. And we're talking about extending those chains all the way out into user space. Okay, so this is kind of our hardware partners and drivers associated with our hardware. Do not read this entire slide. This is just an example of all of the different disk drive firmware we have out there that we need to manage. This is Seagate, Samsung, Western Digital, a whole bunch and more. Disk drives don't have drivers, obviously. They're managed directly by their host bus adapters, but they do have firmware, and sometimes you will need to patch those firmwares. Which brings us to the service pack for ProLiant. Now, this is a collection of drivers, firmware, and agent software. It specifically works with HPE ProLiant branded hardware. It's not going to work with anything, any other odd types of hardware. It's really for ProLiant stuff. And it's specifically for SUSE Linux Enterprise Server. So like all the drivers would be built for SUSE kernels and things like that. It contains drivers, firmwares, and agent. So the firmware, every year now and then we'll put together a big collection of firmware and make sure it works with the drivers and combine it with the agent software and release it all in one bundle, usually in an ISO image, but we also make individual component downloads as well at downloads.linux.hpe.com, which we'll talk about at the end here. And this is also consumed by the HPE Smart Update Manager, which is kind of an enterprisey approach to applying updates to an HPE server and operating system. So that's the service pack for ProLiant, and we're going to talk about each one of these in turn. So let's see, what can we say about the drivers we put in here? So we work with SUSE and other distribution partners to provide drivers, out of distro, so you could get it from HPE. But we also support the drivers that are in distro. So all the drivers that come with SLES are equally supported. So you can get a driver from HPE, you can get a driver from SUSE. We'll support both of those, and we'll work together to support those. We won't just throw it over the wall, right? The thing with the drivers that we're building with our partners, they're often tested with current firmware bundles. A lot of times, if there's a subtle change to a piece of firmware, you might need to make a change to a driver. We'll work with SUSE to make sure that those drivers are released in that errata. Of course, I assign all of these drivers with the secure boot keys that are in NVRAM and every ProLiant shipped. In fact, we ship the SUSE key, secure boot key in all of our ProLiants as well. So you don't have to fumble. If you do install a driver and you're using secure boot, you don't have to fumble through the secure boot public key enrollment process. We'll take care of that for you. This is probably old data here. I used to say, there's 300 drivers in every SPP, and there used to be, because SUSE used to have like 5 different kernels. There's a 32-bit kernel, PAE kernel, Zen kernel. Um, there was a bunch, and the default kernel. And we used to have it build a different driver for each and every kernel because all of the ABIs and symbols are different. Well, luckily, SUSE figured out how to consolidate all of those kernel features into one monolithic default kernel. And so now we just produce one set of drivers for the default SUSE kernel. So that was pretty cool. That was a big win on SUSE's side. We really appreciated that one. This is kind of the anatomy of a driver. If it's kind of remedial for some of you at an engineering conference, but if you type mod info in the name of a driver, this Broadcom driver, you can see some information about it. The version, I wanted to mention the version because it's really hard to have an ordinal value here. This 226 makes sense right now, but it could be any string that the developer puts in there. It could be ABC 123. It could be Kitty. It could be anything. I don't know. Is Kitty newer than 226? I don't know. And with the 5 series kernel, it's even more obfuscated. I think they're just using the kernel version to which it was committed as the driver version. So it can be tricky to know if this driver is newer than that driver. So that's just a consideration. Of course, there's what hardware this thing's driving in the description field, and then Michael Chan here. I don't know Michael, but I have a lot of respect for him or anyone who would put their actual email address into the mod info for a driver. So anyways, if you had a real problem with this driver, you could contact Michael if you wanted to at Broadcom. So this is kind of an anatomy slide. It tells you what's inside of a driver RPM. In fact, SUSE makes something called an KMP RPM. That's kernel module package. So if you want to have a supplemental driver or an updated driver, they have a cool process where you can roll the driver into this KMP RPM, and it'll survive kernel errata upgrades and things like that. The anatomy is really simple. We drop the driver into the updates folder here in the kernel module tree. And maybe a little configuration there for Draycut to make sure it gets into the initial RAM disk. But this is a KMP file. So when you get a driver from HPE, we're going to use the KMP RPM process. And just a note on the driver priorities. So, when you install a Linux kernel, there's a bunch of modules in lib modules, kernel version, and then there's directories under there that, I don't know, most people probably don't even know what they're about. But drivers are pulled out of those directories in a specific order, and that order is defined in depmod.conf. So for SUSE, you're going to notice it searches for drivers and updates or extra or weak updates. And lastly, it's going to search the default built-in kernel for drivers. So if you post an updated driver, or an extra driver, go ahead and drop it in one of these folders and it will be used in lieu of the built-in driver. So that's kernel module packages, and that's the way SUSE has made it really easy for us anyway to install or to build and install out of distro drivers. In the long run, we would really like to have all drivers pushed in distro. SUSE makes great operating systems. I don't know why people want to come to HPE for, to get parts of a SUSE operating system. We should just go to SUSE. So that's what we're really working towards. So that's kind of on the workbench to have that flawless initial experience, have all of the drivers be the latest versions in every SLES that you ever install on a ProLiant. No drivers disks, no fumbling with the KMPs necessarily. And of course, there's clearer support expectations too if you're getting all of your software or hardware from a single location. I presented this at the SUSE Labs a few months ago in Prague, and this is kind of a new process for us where we're actually allowing option vendors, like you could go to Marvell, for example, and buy a NIC, put it in an HPE ProLiant server, and expect it to be supported, and it should be, because what's the difference between you go buying the NIC or us buying the NIC and putting it in a ProLiant server? It should work exactly the same. It is a supported configuration. So what we're trying to do here, at least what I'm trying to say with this slide, is we would really like to have more of a three-way conversation between SUSE, HPE, and all of the option vendors out there to make sure that we can get drivers, posted into the Git kernel. SUSE will work with us to backport the drivers, once they're marked as stable, get those into SUSE and increase the communication between SUSE and all of the option vendors out there. So more of a three-way conversation because traditionally it's just an HPE, a SUSE conversation. Which leads us to the HPE SUSE release cadence. Unfortunately, they never line up, right? It's always the worst case gap. SUSE is going to have a drop dead deadline, at one date, and then we're going to have, a hardware completion, just after that or months after that. So the trick here is to, basically accelerate our schedules or increase the frequency of our releases if possible. This is an old thing here that hopefully there's no new information here. This is all public info. So they'll have like a code drop deadline. In this case, would be October. But we've got hardware that's being completed during that period, all the way out here in April. So if this hardware changes in this time, we need to we might have to patch drivers or make new commits. So we're constantly working with bridging the gaps in our release cadence to make sure that this hardware released here works with the latest version of SUSE. So in this case, it would be SLES 15. SP1 would work with our Snap One deliverables. ProLiant hardware. So anyways, this is the release cadence. This is something we talk about a lot. I just thought I'd mention it. So you get an idea of how we work together on our product cycles. All right, so drivers, firmware, and agent software. That's what goes in the service pack for ProLiant, those three things. I said it again. So let's talk about firmware a little bit. We used to package firmware into SCSIs. These are self-extracting shell archives. They were very last century. Just the security implications alone on those are just unacceptable. So we moved all of our firmware into RPM packages. So now they're cryptographically signed. They work with Linux native, they have Linux native flashers inside them. You can use yum or apt or DNF. To acquire firmware since they're in Linux native packages. Each service pack for ProLiant often has 100 or plus firmware updates. So we are constantly updating the firmware in our hardware, and we're making sure it's easy to flash and manage on SUSE. This is the anatomy of a firmware RPM. I'm not going to get too into this, but the takeaway from here is just run the setup command that's in the RPM. When you install a firmware RPM from HPE, just run setup and it'll run the OS native flasher. Now that I told you everything about how we're packaging our firmware into RPMs and how great that is, I'm going to tell you we're going to change it again on you. So we are in the transition period of going from RPM packaged firmware to fwpkg packaged firmware. And then we're not doing this just to make your life miserable. Personally, I really do think this is a step in the right direction. The key difference here with fwpkg files is there's no operating system object code there. There's no flasher in it. All you do is hand a fwpkg file to the ILO card, remember our management processor, and it takes care of all that. So the benefit here is obvious in that you can flash firmware with any Linux distribution you want, any operating system you want, or no operating system at all, right? You can remotely flash firmware on a system that hasn't even been provisioned yet, so long as the ILO card's powered on. So that's what fwpkg files are. You're going to start seeing more of these as we migrate firmware over to that packaging format. Um, and of course, this is a kind of a cool DevOps sort of oriented approach because we're using Redfish, right? RESTful interfaces to do all of this. A lot of open source or open standard processes to flash firmware now. So one of the downsides is that RPMs or fwpkgs aren't recognized by zipper or yum, which was kind of a cool feature when we had RPMs. You used to be able to do zipper search, DL380, and you'd find firmware RPM for DL380. That obviously will break. So I came up with a new thing called fwget. This is on the workbench. Actually, I just released fwget a few days ago. So fwget is kind of like apt-get or wget all smashed together, and you can use it to search our online firmware repositories, much in the same way that you used zypper or apt or dnf to find Linux software. And once you fwget a firmware, you can then use ilo rest, which is just making RESTful calls over Redfish to the ilo card that will flash the firmware. In fact, this is a command line example of fwget in action. Again, this is brand new. I really haven't told many people about this at all. So this is kind of almost a SUSECON exclusive. We just had a soft release on this. So fwget search DL380. You see a couple of firmwares pop up there. Hey, here's a Gen 10 one. I'll do fwget download that firmware. It downloads it. And then I use ilo rest with the flash fwpkg option to flash the firmware. It's really that easy to flash firmware. And this doesn't have to be on the target system either. You could run this from your Ansible server. That's the cool part about this. You can cut and paste this into Ansible. So we really want to embrace the DevOps kind of approach to managing firmware, much in the same way you would manage software, right? If you want to get crazy down here, we have extreme command line tool chaining. You could do all of these steps in a single command. I don't know why you would, but you could if you had to, I suppose. All right, service pack for ProLiant, drivers, firmware, and agent software. I said it again. Let's talk about the agent stuff. So what is an agent? Anything in the SPP that isn't firmware or a driver, right? Um, so this is our user space stuff to help manage Linux on HPE servers. So AMSD, this is kind of an important one. This is the daemon that talks to the HP ILO driver that we talked about initially to get all of the SNMP events into the ILO hardware. So the ILO hardware doesn't know like if a file system is full. It doesn't even know what a file system is. It knows what disk hardware is, but it doesn't know the logical constructs of an operating system. So AMSD kind of bridges that gap by sending operating system information to the ILO card so you get a complete picture of your hardware health and operating system or logical health as well. So that's AMSD. So go ahead and install this on all of your Linux systems. This is widely supported across Linux distros. I grouped these next three together, the system management homepage, SNMP agents, health agents. I grouped these together because these are all deprecated now. All of this stuff was moved to the ILO card itself. It'll look real familiar. So if you're running Gen 9 or old hardware, you need to install these. This honestly, this is a million lines of code, and we had a lot of trouble installing this on newer operating systems. And when I say we, I mean me compiling this. So I'm actually really glad this moved over to the ILO card. So don't install this stuff on Gen 10. Another big one is SSA CLI, the Smart Array Command Line Interface. If you know one command syntax for this, it's how to show the health status of all the drives in your array, right? So this is the command for that. HP on config is to store and load ILO configurations, and there's more stuff here. I'm not going to get into the details. Those are the important agent softwares that you need to be aware of in the service pack for ProLiant. Now, outside of the service pack for ProLiant, there is additional stuff. I don't know if I can move my picture out of the way here. I'm bottling the text here. The system update manager, we talked about that. That's a little more enterprisey approach to managing system. It's a really double clicky. So to install drivers, firmware, and agent software, it'll do all of that in one go. It really understands how all of the stuff works together. The management component pack, this is the agent software out of the SPP, only we support it on things like OpenSUSE or like CentOS or Debian or Ubuntu. a lot of the other community-driven Linux distributions. So we'll support the agent software out of the SPP there, and we call it the MCP, just to keep you confused. That stands for Management Component Pack, and this is for the other or community-based Linux distributions. ILO REST, we talked about that earlier. This is basically implements the Redfish API in a cool command line interface, so you don't have to memorize all the URLs using curl or wget or whatever you use for RESTful stuff. For the sake of time, I won't belabor all of these guys, but there's a lot of software. This is just some highlights, right? If, like I said before, there's one URL that we can take away from this presentation, it's going to be, I'll get myself out of the way here, downloads.linux.hpe.com. These are all of our online software repositories. So, the days of downloading an ISO image or even a TGZ or even using a web browser to get software, I mean, those days are over, right? That's really last century. I understand, the DevOps community is going to want all artifacts in online repositories. That could be RPMs, DEBs, or firmware or everything. It needs to be in an online repository. It needs to have some sort of RESTful interface. So this is that. So um, all of the software I just talked about is in online repositories such that you can acquire it with Zypper or DNF or apt. So if you want a Broadcom driver, you can type Zypper install BE2net KMP default, and it'll install the latest BE2net driver depending on the repository you've subscribed to. And they're all broken down by versions of SLES and Service Pack. So that's downloads.linux.hpe.com. That's a good one to remember. Like I said, this is broken into multiple repositories. So all of the SPPs are here for each different generation of ProLiant. And I also took the firmware out and put them in their own repositories just because I thought they deserved to have their own repository. So all of our firmware RPMs and fwpkg files are broken out by Linux or ProLiant version as well as SLES version. Though, like I said before, firmware is OS agnostic, so it doesn't matter what version of SLES you have. You can subscribe to those repositories. Additionally, as a side note, so for Gen 10, we do not require warranty or support to acquire firmware anymore. We do require this authentication so using your HPE Passport login, but yeah, you don't need warranty or support for firmware with Gen 10 and forward. So I thought I'd mention that in this presentation as well. And that concludes this. And hopefully I got this in under 30 minutes. I wish I could answer your questions live here, but we're doing the best we can with this virtual event. And I would really like to thank you for attending the sponsor session in particular. I'd like to thank SUSE for hosting us here. We like to attend SUSECON every single year. And also I'd like to thank the open source developers at OBS, Open Broadcast Server. That's what we're using to record this. So yeah, great piece of software. Thanks, guys. Okay, I'll see you next year at SUSECON, hopefully live. This is Craig Lamparter with Hewlett Packard Enterprise. Thanks.